Hello, GED students. Welcome to a virtual GED class. Today, we're talking about something that seems so simple and yet stumps so many students, the basic operations. Basically, adding, subtracting, multiplying, dividing. That's what we're talking about today. And so you might be asking, well, why are we going to do something this simple, Kate? Why do you want to bring it back to this? I really have a lot to do in my life. I need to pass this test already. I don't really want to talk about adding, and I get it. But what I would argue is that if you really understood addition, subtraction, multiplication, and division the way that you need to, you wouldn't struggle the way that you do in algebra. Y'all tell me, I know how to do that. And yet, as soon as I throw a letter in, you don't remember what plus means anymore. We have a student with me here today. I love it when I have a student in the class because you know what they're going to do, you guys. They're going to ask the good questions that you would want to ask if you were here. But also, Shamika's going to let you know when I don't make sense. She's going to be like, slow down, Kate. That needs to be explained. So she's here for you guys. So Shamika, if I use the word operations in math class, do you know what I'm talking about?
What's a perform?
Ooh, I like that word, perform. It's an action. Yeah, operations are definitely actions. They're what we perform. There are processes. They're what we do to take our input values, some starting numbers, and get an answer, an output value. Yeah, they're the things that we do with numbers. Let's talk about the first four. The most basic operations, the one probably that we all first learned. So, after we were good at counting and writing our little number symbols in math classes way back in the day, we learned an operation. The first thing we learned to do with numbers was put them together. We said, well, Johnny has 3 candies and Jimmy has 2 candies. And then we'd say, how many candies do they have all together? And we had a mathematical operation to tell us to do that. Shamika, do you know what operation told us to put those groups together?
Yes, addition.
Beautiful. But we didn't just stop there at addition. We learned to work backwards. We said if we could put those candies together, there's got to be a way to reach back in and take out a group. And so we learned the opposite of addition. What's the opposite of addition?
Subtraction.
Beautiful. And then we didn't stop there. Mathematicians are lazy people. We're all about shortcuts. And so we noticed there had to be a faster way when we had repetition. We said, well, what if Jimmy has 5 and Johnny has 5 and Tyrone has 5? So does Lucy and Lindsay. Everybody in the whole class has 5. There's got to be a way to put a bunch of 5s together. And so we learned a new operation. What operation was that?
Multiplication.
Multiplication. Beautiful. And then, of course, if we could put together the same amount over and over again, there had to be a way to move backwards, to take them back apart. And then we learned the opposite of multiplication. And what was the opposite or inverse of multiplication?
Division.
Beautiful. So those are the 4 basic operations we're going to talk about today. Simple, right? We should be okay, right? But we're going to look at those in some great GED contexts. All right, let's give it a try. First thing is I just really want to get the basics down. Let's talk symbols. Let's talk terms, some really important vocabulary words you need for the GED. And then let's talk definitions. Again, not how to do these things, but what do these operations do? Okay, let's start easy. Let's start with those symbols. I haven't had a student yet who didn't know the symbol for addition, that little plus sign that you're used to. We're going to use that in algebra. You don't have to learn a new symbol for addition. Same thing with subtraction. That minus sign you learned back in the day is still going to be your friend. Good news, nothing new to learn. However, once we get to multiplication, things are about to get a little trickier because that time sign that you learned probably in 2nd or 3rd grade, I'm not really going to use it come the GED. There's a few other ways to say multiply. Shamika, do you know any other symbol that signifies multiplication?
Yes, a dot.
Sure, I could use a dot and make sure it's up in the middle here, not sitting on the floor. It's going to look like a decimal point, but I could put a dot between 2 numbers and that would tell us to multiply 5 times 6. Now that dot is frequently used in computer sciences. So if you're going into any kinds of a field that involves computers, you might see that dot or you might see a star little asterisks between the two numbers, and that would be another way to mean multiply, but still not the way we'll probably see in algebra. Do you know how we would signal multiplication in algebra?
Yes, parentheses.
Parentheses. Oh, I love that. So like if I had the number 5 and then I shoved it next to the number 6 with only parentheses between them, absolutely, that would be multiplication. Now the parentheses could be on just one number or they could be on both. But the key here is that the only thing between these two numbers is parentheses. Now I need to tell you something really important. Parentheses don't always mean multiplication. They don't always? No. In fact, I'm going to show you two examples. You don't need to necessarily write this in your notes, but I want to look at this versus this. These two expressions look really, really similar. There's only one symbol difference. Do you see the difference between them, Shamika?
There is a subtraction sign in the middle of one of them.
Absolutely. In the first expression, we see that 5 is shoved right up against that parentheses. But in the second one, the 5 and the parentheses are separated by another operand, a symbol that tells us about an operation. And so one of these says multiplication and the other one does not. The first says 5 times -6, and the second one says 5 minus -6. So how am I supposed to know when parentheses are being used to multiply or they're being used for some other thing? Because parentheses in algebra class are actually used for quite a few things. The key is proximity. It's not really the parentheses that are important. It's actually really the fact that they're shoved together with only parentheses between them. And sorry if I'm using big words, you guys. Proximity means closeness. So it's the closeness that tells us here to multiply. Make sure that gets into your notes because that's something that really confuses a lot of students. Not just parentheses, it's parentheses with proximity. One more thing is, as it turns out, the parentheses aren't even always needed. Sometimes proximity is enough. Shamika, if I wanted to multiply with variables, with mystery numbers like X, some unknown number, and I wanted to multiply 5 times X, I wouldn't use parentheses. Do you know how I would write that?
Yes, you would just write the number and the variable close together.
Exactly. I would just write the number first and the variable or letter second. We don't even need parentheses here. Just the fact that they're shoved together tells us that they're multiplying. And I always have a joke about this because I'm like, seriously, you guys, if you were walking down the street and you saw, I don't know, your boyfriend shoved up next to some other woman real close, you'd be like, oh, he's multiplying with somebody else. So same thing here. You see a 5 and an X shoved up real close to each other. You know they're multiplying. That's why he's the X. All right. He's off multiplying with some other 5. The point here is that proximity is enough to tell us about multiplication. So you're going to see 5X on the GED, but you're going to go to college. You're going to see other areas where it's just proximity that's telling you multiply. Like you could see some tricky things in your college classes, like this 5 shoved up against this square root of 3. And if you don't understand that the two things being shoved together means those two things are multiplying, you're going to get lost. The main way that we are going to signal that we are multiplying in algebra is actually proximity. Now, sometimes it's proximity with parentheses, because if I just shoved 5 and 6 together, you wouldn't know they were multiplying. You would think 56. And so I've got to use those parentheses to separate the 5 and the 6 enough so you know they're multiplying. But it's the proximity that's really going to clue us in. That was a tricky new concept. Some students say, Kate, why do we need a new way? Really, the times sign has been working for us. 2 reasons. First reason is because if I write this, what does that say? Does that say 5xx? Does that say 5 times X? Does that say 5X times? I have no idea what's going on there. And so now that we're using X to mean a mystery number, an unknown number, it can get confused with the time sign. So that's one good reason to drop it. But I have another good reason. And that is parentheses can be used for both multiplying and they can be used for grouping. And we're going to need that power in algebra. Okay, let's move on to division then, because I'm going to do the same thing to you that I did with multiplication. This is like one of my pet peeves. I put it on Twitter the other day and I said, could we please stop using this symbol, which confuses every student. And I wanted to use a different symbol instead. So I'm not going to use that for divide by in algebra class. Do you know what I'm going to use instead?
A division bar.
Also known as the fraction bar. If I want to tell you 6 divided by 3 in algebra class, I'm probably not going to write it that way. I'm probably going to write it this way: 6 divided by 3. And I know half of you guys have turned off the video in fear. The other half are in the corner, fetal position. You're so scared of fraction bars. But that's exactly why I want to normalize this from the very beginning of math. All this means is 6 things divided into 3 groups. If you were to simplify this, it wouldn't be a fraction anymore. 6 divided by 3 is 2. We need to stop being scared of fraction bars. They literally just mean division. Now, some of you guys might say, well, Kate, what about this? That's scratch work. That little division house that you used to organize when you did long division, it's not part of my language. It was a way for your 3rd grade teacher to teach you to organize your work. I do not want you using it in algebra class. We're going to drop it. We're learning to communicate like mathematicians, not do our scratch work like a 3rd grader. In fact, I don't care if you ever learn to long divide. But what I do care about is that you can write in the language of algebra. And so I need you to use this fraction bar for division. And same reasoning as before. Why do I want you to use this symbol? Well, as it turns out, fraction bars are much more powerful as well. They also can be used both to tell us to divide and to form groupings. And you'll learn more about that in lesson 5 on the order of operations. But for now, trust me, you guys, you want this kind of power. And just another note, please don't do this. Now, I know you say, okay, I always do that. I love my little diagonal fraction bars. Jamaica, you're nodding at me. Do you use the diagonal fraction bar?
If you would have asked me for another way to show division operation, I would have said that slash.
Yeah, and it's just 2 different ways to write the same thing. But the only reason I ask you not to do it is because of me working with students with disabilities. So a lot of students struggle with symbols. And so if you're one of those who the numbers dance, they flip, those symbols really mess with your brain, this actually increases that tendency. In fact, I can bring my test averages down in my classes just by taking every fraction bar and turning it that way. That's how impactful it is on you guys' symbolic processing. So just don't do it because you love yourselves and you want to do well on your test. Let me teach you 4 important vocabulary words. First one we are going to look at is the word sum. Most students I run into in a GED class have heard the word. They kind of understand it, but they make a mistake in thinking that all that sum means is a plus sign. Now, it has to do with addition, but it doesn't mean plus sign. A sum is what we call an addition expression. There I go again, using a math term that maybe you've never heard of, but that's because you and probably your 3rd grade teacher, who I'm sure she was lovely, she probably brought you cookies, but probably didn't use this word, right? She probably said the problem. Because when I refer to an expression, I'm talking about not just the plus sign, but the numbers that I'm adding here. This is the sum of 5 and 6. But that's not the only thing that the word sum can refer to. It can also refer to the simplified expression. Simplifying in math just means performing the indicated operation, like doing the math that the expression told you to do. So when I talk about the simplified expression, I'm talking about the output, what you guys think of as the answer. So 11 is a sum. Now you might say, how is it a sum? There's no addition there. Well, it's the sum of 5 and 6. Now let's move on. We're going to learn about a lot of words like this. Next one is difference. It's really similar, but there's something important about difference that is not true of the rest of them. A difference is not just a subtraction expression. It is a positive subtraction expression. Sometimes in life, you can subtract and end up with a negative number. For example, I was a single mom for a long time, and I definitely had the experience where I only had $5 in my bank account, and then I took out $30. And then I was in trouble. My bank account went negative, and that would be subtraction, but that would not be a difference. If I were talking about the difference between two numbers, I would have to make sure that my answer was positive. So for example, 25 minus 6 is the difference between 25 and 6. But if I wanted the difference between 6 and 25, I wouldn't write 6 minus 25. I'd still write it this way, 25 minus 6, because I would want a positive answer. So a positive subtraction expression, or it's simplified, what you guys think of as the answer. 25 minus 6 is the difference between 25 and 6, or the difference between 6 and 25. You can read it either way, but you could also say 19 is the difference between 25 and 6. With this idea of difference always being positive, I actually have to introduce a fifth operation to you today. Not so basic, but important when I use the word difference. Because if I tell you what the numbers are, 25 and 6, it's easy to make your answer be positive. All we had to do was put the bigger number first, smaller number second. But what if I had mystery numbers? What if I told you that there were two mystery numbers I didn't know, X and Y, and I wanted you to find the difference between them? Well, they're mysteries. I can't tell which is bigger. Is X bigger or is Y bigger? So I need a way to say subtract, but whatever answer you get, make it positive. Don't worry if this is a little over your head, because we're going to go into it in a lot of depth in lesson 4 when we talk about integers. But that operation is absolute value, and it is signaled by these up and down bars. It means whatever answer you get, make it positive. So put that into your notes, but don't worry about it too much. Just kind of let it roll over you. Okay, there's another operation we're going to be looking at a little later. So we have sum, which is an addition expression, or its simplified answer. We have difference, which is a positive subtraction expression, or its simplified answer. But do we have one for multiplication and one for division? We sure do. The terms there are product and quotient. A product is a multiplication expression, or its simplified answer. Again, it's not really called an answer, but you guys, I'm trying to speak your language. So the product of 5 and 6 could be written this way, but I could also say 30 is the product of 5 and 6. Okay, it can refer to what you think of as the answer. And then the same thing with quotient. If I ask you to find a quotient, it is a division expression, or the simplified expression, what you guys refer to as the answer. Woo! 4 important words: sum, difference, product, and quotient. They're all kind of the same thing, but remember that one little trick about difference: it has to be positive. Ooh, one more thing. Oh, I almost forgot. There's a synonym for difference that comes up on the non-calculator section a lot, and students don't realize it means the same thing: distance. In fact, that's why difference is always positive, because you're measuring the distance between two numbers. You can't have negative distance. Like, it'd be so silly if I said, Shamika, how far did you walk to the store? Shamika told me I walked to negative 50 feet. I'd be like, how'd you walk less than 0 to get to the store, girl? Distance, difference, they mean the same thing. They're both always positive. Okay, let's clear all this and take a look now at the definition of addition, subtraction, multiplication, division. I love asking students this question first day class. I just sit back and wait for the answers, because I got students in my class, they've been adding their whole lives, and I ask them, okay, I don't want to know how to add. I want to know what it means to add. And they get stumped. I'm going to do the same thing to you. I'm going to put you on the spot. Shamika gets real rude. But what does it mean to add?
You're putting them together.
I am definitely putting them together, but addition is not the only way to put things together. You can also put things together with multiplication. So I'm going to need a little more clarity than that. How's adding different than multiplying?
I'm not sure.
Exactly. Isn't that rude? I mean, I should real jerk. She's like, aren't you the math teacher? Could you just let them know? But I want everybody out there to just sit and think about it. What's the difference between addition and multiplication? They both put things together to find a total. But think about what we said at the beginning of class. When we were adding, we said Jimmy could have 5 candies and Johnny could have 6. But when we were multiplying, that wasn't the case. If Jimmy had 5 candies, guess what? Johnny had 5 candies too. So when we're adding, we're putting together any sized groups. It doesn't matter how many candies Jimmy has and how many candies Johnny has. In fact, they don't even have to have full candies. They could have any size group or they could have any sized piece. Johnny could have a half a candy and Jimmy could have a quarter of a candy, and I could still put it together. But there's one more important thing. It's not just any size group or piece. It's any size group or piece of the same thing. Johnny had candy and Jimmy had candy. Y'all do weird things in word problems. You'll add like candy and pumpkins, and then you'll tell me you got candy pumpkins. I'm like, what the heck are you doing? I can put together candy and figure out how much total candy, but I can't suddenly throw pumpkins into the mix and try to turn it into candy. So putting together any sized group or pieces of the same kinds of things. And when I talk about the kinds of things, I'm talking about the unit. Dollars with dollars, candies with candies, yada, yada, yada. So now how is that different from multiplication? When we said we were putting together in multiplication, we said it wasn't any sized groups. It had to be what?
The same.
Exactly. They had to be the same. So then when you're multiplying and you say 5 times 6, this is not 5 candies times 6 candies. That's why we read that as times. So we'll have 5 candies 6 times. So one of them is the size of the group, but the other one is the number of groups. So we're putting together some number of same-sized groups or pieces. Cool. So I have addition and I have multiplication's most basic definitions down, but I have to talk about something super important, and that's that this is not the only definition of multiplication. And you guys really struggle because suddenly in 4th, 5th grade, we started having problems. Like you guys were expecting that when we add, when we multiply, things get bigger. And it doesn't always. We introduce negative numbers and all of a sudden we can add and get things that are smaller. Well, that's weird. We introduce fractions and all of a sudden we can multiply and things get smaller. That's weird as well. So another important definition you need to know is that multiplication can also be used to scale. So yes, it can be used to put together some number of the same size groups or pieces, but it doesn't have to be many groups. In fact, you can use it to scale. You can do part of something through multiplication, and that feels wrong to students. So Shamika, do you do any kind of art or even just play on the computer ever?
I play on the computer often.
Have you ever had an image that you wanted to make bigger or smaller? And so you could scale it up, but you could also scale it down.
Yeah, cropping.
Like cropping, but when you take the whole image, you don't lose anything and you compress it or you bring it out. That's what I mean by scaling. That's multiplying. Whether you make your image 2 times larger and it got bigger, or you make your image half as large, you take half of the size, then you're actually multiplying by 1/2. Either one, whether you pull it up big or you pull it down small, is an act of multiplication, enlarging or decreasing size by a scale factor. So I argue that if we understand these operations, these way of putting together numbers, then we should understand their inverses. So draw yourself a little arrow. It's super important to understand this math word inverse, which just literally means opposite operation. So if addition is putting together any sized group or piece of the same kinds of things, then what is subtraction?
Taking away.
It is taking away, and it's removing a piece or a group. Now, careful, I didn't say subtracting is getting smaller. For example, if I had $5 in my account and then I called the bank crying. I just called them crying. I used to do that as a single mom. Okay, but you may put a charge on my account and now I have no money for groceries. I would like you to take away the charge of $37 that you charged me so I have some money to buy some diapers for my children. If they took away something off of my account would go up, but yet I have subtracted. I took something away. The opposite there then of addition. So let's look at division then as the opposite or inverse of multiplication. So we said multiplication was putting together some number of same-sized groups or pieces. Well, then what's division if it's undoing that?
I'm going to have to say like breaking them into pieces or groups or parts.
Yes, you're breaking a total into some number of same-sized pieces or same-sized groups. Now, interesting thing, because I said that multiplication was scaling. It could be used to enlarge or decrease a size. Now, a lot of students think, well, no, division decreases the size. No, when we multiply by something small, decrease size. So then what's division? fraction, what's the opposite in regards to scaling? That finds the scale factor. It can figure out how many times larger or smaller something got. Did it get twice as big? Did it get half as big? I don't know. Divide to figure it out. All right. Woo, woo, woo. As usual, Kate talked too much. We need to see some problems. I promised you some GED applications of these basic operations, okay? So I'm going to look at 3. These aren't the only ones. But the first one is just building up your mathematical reasoning. The GED is a mathematical reasoning test, meaning you kind of have to be a thinker and you have to break things down and be able to answer puzzles. And that's the kind of test it is. It's not just like, do you know your math steps? Not that kind of test at all. But it's not only like the GED where you need mathematical reasoning, it literally helps you in every area of math. If you have mathematical reasoning, I can teach you a concept like I do with the basic operations, and you will know how to do all kinds of things instead of me needing to teach you, here's how you do this, and here's how you do that, and here's how you do this. I'll go to teach you something new and you go, oh, of course it's like that because I understand addition. Let's look at an example of that. We talked about one way to think about addition is that it combines any sized group or pieces of the same kind of thing, the same unit. As a math teacher, I can only teach this one thing instead of 8 other classes. Literally, let me show you what I mean. First example, I got 3 examples of students doing their scratch work for addition. And which one's the process you would use if you wanted to add numbers on paper?
The third one.
The third one, but why? Why would you line it up that way?
I'm not sure.
Yeah, you're like, because Mrs. Johnson told me to.
Exactly.
Yeah, that's not mathematical reasoning, right? That's memorizing Mrs. Johnson's very sweet instructions, but you don't have any understanding. Shamika, did you ever talk about place value in your elementary school?
Okay. Yes, starting at the ones place.
So look over this example on that right-hand side. I want you to notice what I have lining up here. This 4 is in the ones place. So is that 6. That's 6 ones. So if I line it up this way, I'm adding ones with ones. I'm adding the same kinds of things. There's not some magic to the right-hand side. The left 2 are not wrong because I forgot the steps. The left 2 wouldn't work for you because I'm not adding the same kinds of things. I'm trying to add hundreds with ones or ones with tens. It's just not going to roll. But that's not the only place we'll use it. This is a fun question to ask my students. I just ask and I just lean back and I let them fight about it. So I'll ask you now, what's 8 apples plus 6 oranges?
14, but it's not the same.
Yeah, so 14 what?
14 pieces of fruit.
We can't have 14 apple oranges. They're not going to suddenly morph what they are if I put them together, right? There's still going to be apples and oranges. But because Shamika used that language, she said, oh, they might not be the same type of fruit, but they're both fruit. As soon as they were the same, then I could add them. Okay, so one rule. We got 2 applications here. Y'all are better at word problems. Y'all are good at the addition algorithm, but that's not it. Okay, let's look at another place you guys struggle. If I ask you to add 14.3 and 0.95, those students who loved Mrs. Johnson's class and learned the rules so well because she brought the cookies, now go and line this problem up like this on the right-hand side and get wrong answers. Any idea why all of a sudden now it's wrong to line up on the right? How come it doesn't work here?
The decimal places aren't aligned.
That's what your 3rd grade teacher taught you, right? You got to line up at the decimal place. Good rule. Just like they taught you before, you have to line up at the right. But I said I was going to give you one rule. So look at this one rule. It says that addition is combining any sized group or pieces of the same kind of thing. So it's not about the decimal, but what am I doing when I line up at the decimal?
Something to do with place value.
Exactly right. If I line up at the decimal, I'm aligning place values. I'm aligning, again, ones with ones, tens with tens, but also tenths with tenths and hundredths with hundredths. Because that decimal point holds place value, that's a way of making sure all my place values are in line. Three different processes, one rule. Let's look at another. Here's some issues that students really, really have, usually in word problems. Okay, it's not just plunked out like this, but I give them a word problem where I'll say like, oh, I don't know, Kate had 5 cents and Shamika had $5. How much did they have all together? And people will tell me $10. I'm like, I wish that my 5 cents was that powerful as soon as I met Shamika, but unfortunately, that's not how it's worked in the real world for me. So if it's not 10, what is it?
$5.05.
Yeah, I love it. It's $5.05. So I can't put that together. Now, could I do some math and convert so that I could say it's $5.05 or it's 505 cents? Yeah, I could turn them into the same kind of thing and then I could put them together. But the easiest way to think about it is just $5.05. And same thing with feet and inches or hours and minutes. And yet you guys will do these word problems where you just shove together any random number you see. You're just like, I don't know, it's addition. So let me just shove some numbers together. But adding is putting together the same kinds of things. It might not need to be the same size group, but it does need to be the same unit. Sweet. Let's look at another example. I'm going to make you cry. Good news. This is not an adding fractions class. And in fact, you will find no adding fractions class on my crash course at all. Why? Because it's not that important to the GED. But you know what is important? Understanding addition. So I want you to look at these two expressions. I have 3/5 plus 1/5, and I have 3/5 plus 1/4. And I would argue that one of these is really simple, and one of these is more challenging. Which one of these two expressions would you rather simplify?
The one with the same denominator.
Heck yeah. The one where I'm putting together fifths and fifths. So if I have 3 of this kind of thing, this fifth, and I add in 1 more of this kind of thing, this other fifth, then I'm going to have 4 total. 4 total what? Still fifths, not tenths. They're not going to change what they are just because I group them together. Of course, this is a lot trickier, as Shamika can tell you, and we won't learn today, but if I wanted to do 3/5 and 1/4, I could not add right now because they're not the same kinds of things. These are fifths and these are fourths. I would have to do some additional work to give them what we call a common denominator, but to make them into the same kinds of things. Look at that. Even fractions obey my one rule. Okay. We got through the basic maths. I'm going to freak you out a little bit, but you're going to be okay. Algebra. Y'all lose your minds as soon as I throw X's and Y's up on this screen. But that is not where I want you to focus, Shamika. I want you to look at the first expression. What am I asking you to do with 8X and 6X?
Add them together.
Add them together. Adding together combines any size groups of the same kinds of things. Well, I got the same kinds of things here. I have 8 X's and I have 6 X's. If I have 8 of something and I put it together with 6 of something, then I have how many?
14.
14. And you might say, but 14, what? I don't know what to do with X's. Well, you guys, if I had 8 apples and 6 apples, I'd have 14 apples. If I had 8 pumpkins and 6 pumpkins, I'd have 14 pumpkins. If I have 8 X's and 6 X's, guess what I have? 14 X's. And you say, but I don't know what X is. And I say, I don't know either. But whatever he is, I have 14 of him. And then I have another problem that students really commonly get wrong. You guys are sweet. I love you. You're wonderful. You start algebra class. You so badly want to simplify for me. You see this plus sign and you're like, I have got to plus for Kate. Kate has told me to plus. And then you do nonsense. You'll tell me that 8X plus 6Y is 14XY. Well, just like putting together apples and oranges did not give me apple oranges, putting together X's and Y's would not give me XYs. It's so many X's and so many Y's. Just like when Shamika, I asked her, what is $5.05? Shamika told me, well, it's $5.05. Same thing here. What is 8X and 6Y? It's 8X and 6Y. I'm not going to put them together. They're not the same. This is simplified. There's nothing to do here. And how do I know that? I know that because I understand addition. So that's my first argument. If you understand the basic operations, it's going to make everything else in math easier. Instead of having to memorize 8 separate different rules, one rule applies over and over and over again. And that is what that operation means. But that's not the only way it's going to help you. It's going to help you so much in interpreting word problems. If you've actually done a GED test, you're going to know you have the calculator add, subtract, multiply, and divide most of the time. But what you don't get is someone telling you when. We can avoid those strategies that GED students usually use. A lucky guess. The mushing and praying, like I have a couple of numbers, I'll just mush them together and hope, or giving up in despair. We need a better way. What will we do instead? We'll understand those basic operations so we know when to use them. First one, let's look at Juana. She has $15.79 on her Game On play card. How many 25-cent tokens can she purchase? So students look at this, as soon as the decimals get involved, they're like, I don't know whether to add, subtract, multiply, or divide. But if I understand what they mean, I should be able to choose the right operation here. One thing, it says Juana has $15.79 on her game card. She already has a total amount. And then it says how many 25-cent tokens can she purchase? We're looking to purchase token after token after token, and they all cost the same amount. So, Shamika, I've got a total, and I'm going to spend it group after group after group, all the same size. What operation am I looking at here?
Division.
Beautiful. Taking a total and breaking it into same size groups. I don't care if the division looks scary, if it looks ugly. You hate dividing with decimals. So do I. That's why I own a calculator. Pick it up and do it. But you needed to know that it was time to divide. Another example. Again, you guys lose your mind when you see a fraction. I can't do fractions. No, but your calculator can. So what you need to be able to do is pick the correct operation. So a recipe calls for 3.5 cups of flour. Joan wants to make a quarter of a batch. Look, I have a batch size and I'm scaling my batch down. Shamika, we learned that if you're scaling, that's an act of what?
Multiplication.
This is telling you to multiply 3.5 and 1/4. Pick up your calculator and do it if you hate it, but you need to know that it's multiplication. Here's another one. The all-time record high temperature in Prescott, Arizona is 105 degrees. The record low temperature is -21 degrees Fahrenheit. Now, look what I ask you to do with these numbers. Find the difference between the record high and record low temperatures. What am I asking you to do?
Subtract.
I'm asking you to subtract them. 105, and we said difference was always positive, so I'll start with the higher temperature, clearly 105. And then I'm asking you to subtract what? What is the other temperature?
-21.
-21. I'm asking you to subtract -21. Now you might say, I don't know how to do that. That's okay. I don't need you to know how to do that. Literally pick up your GED calculator and you could type that in. But I did need you to know that I was asking you to subtract. We are almost done. Hallelujah. We're about to do some algebra. Now, a lot of students see algebra and just panic. I'm not going to ask you to do anything with X's and Y's today. What I really need you to just focus on is those basic operations. Adding, subtracting, multiplying, and dividing. And we're just going to work with those concepts and work on not letting the letters make us forget what we already know. We're going to look at writing algebraic expressions, equations, and inequalities, which comes up on the GED. Now, it's discussed in length in Unit 1, the algebra unit of the crash course. But right now, we're just going to look at those new words of ours in that context. Take a look at this. Shamika, good news. I'm not going to make you do this until Unit 1. But right now, I'm just going to ask you, what are they asking me to do? Find the product of 2x plus 1 and x minus 6. Oh my gosh, these are ugly things. But if I ask you to find the product of them, what am I asking you to do with these ugly things?
Multiply.
And remember, I told you that parentheses are more powerful than time signs? This is one of those cases that if you just use a little time sign, you would get a wrong answer. So super important that you would use parentheses if you were doing something like this. You would take this whole big ugly thing in parentheses and shove it up against that whole big ugly thing in parentheses to say that I'm going to multiply the whole thing by the whole other thing. Now you say, how do I do that? Oh, guys, we'll do it in Unit 1. But for now, oh, that's what they want me to do. Multiply. That's a GED example, by the way. All 4 of these are going to be just so GED typical. And I need you guys not to lose your minds. Don't panic. We can do this. Which expression represents the distance between 2 points, C and D, on the number line? Shamika, I taught you about the word distance, and it meant the same as another one of our vocabulary words. Distance meant the same as what?
Difference.
Cool. And distance or difference talks about a certain operation's expressions. Do you remember which operation?
Subtraction.
Subtraction. So it's definitely one of these two here. But we learned something super special about distance or difference. What did we learn about those expressions?
Absolute value.
Yeah. How come absolute value? Remember what absolute value bar does?
It tells you the distance.
Yeah, but it tells you one important thing about distance or difference. Remember that?
Positive.
That is positive. Exactly right. A distance or a difference is a positive subtraction expression. So this one, even though it looks tempting because it has subtraction, is not necessarily a distance or difference because I have no way of assuring it's positive. But with those absolute value bars around there, it does say that. The positive subtraction expression. Sweet. I didn't need to know much about algebra. I needed to understand the word distance. 2 GED style problems. Woo! First class. Here we go. Another one. Again, I'm not going to get into the specifics of this. There's whole lessons on writing expressions, equations, and inequalities in Unit 1, but I just want to look and focus in on some important information that we already know. So even if I didn't even get through Unit 1, I'd have a good chance of guessing on my multiple choices. Take a look at this. It says, translate the phrase twice the sum of a number m and 12 equals 5. If I ask you for the sum of a number m and 12, what am I asking you for?
The answer.
The answer when I what?
Addition.
Addition. Yeah, if I ask you for the sum of a number m and 12, I'm asking you to add m and 12. Now, I think it's interesting that you said the answer. Sometimes I'll just cut out comments that my students make that don't apply, but I think most students would say that to me. They'd say, I want the answer of m plus 12. But I would say to you, what's m plus 12? How could I find the answer to this? Well, I couldn't because I don't know what m plus 12 is. So remember when we said the word sum, we said it could refer to the simplified answer, but it could just also refer to the expression. This is the expression. This is the numbers, m, some mystery number, and 12 adding. And that's as simple as this is going to get. I can't add them together, but I can at least know that I'm asking you to add m and 12, even though you hate m and it scares the crap out of you. You still know he's supposed to be adding with 12. Now, there's more going on in this problem, obviously. They're asking me to take this whole sum and make twice that, and then they want it to say that it equals 5. And that's all good. And we'll practice that in Unit 1. But for now, what I really want us to focus in on is that we knew what the sum of m and 12 was. We could sit there and narrow out our multiple choices, erase all the ones that have subtraction, cross out all the ones where the m and 12 are multiplying. And right away, we've gotten that much closer to understanding what's going on. Another GED example. What are they asking me to do? Ready? Okay, Maki has some number m of marbles. Some number m? Oh my gosh, it's a mystery. I don't know how many marbles Maki has. Leilani has 5 less than Maki. Very scary, but look, they tell me, or m minus 5 marbles. Okay, so Leilani has m minus 5. Might not make sense to me, but that's how many she has. Kainoa has twice as many marbles as Maki, or 2m marbles. Now, half of you guys turned this video off already. You're just so done with me and my letters. But look at what they're telling me to do. Write an expression to represent their total marbles. Now, we had 2 operations that found a total. Do you remember which 2?
Addition and multiplication.
Multiplication, cool. And the big difference there was addition was when we had different sizes, they weren't all the same. And multiplication is when we had the same. So don't panic. Just look, are they identical? Do these people have the same numbers of marbles?
No, they don't.
They don't. So what operation will I choose?
Addition.
Bingo. She says, but I don't know how to add them. I say, that's okay, but do you know I need to add them? Okay, that's where I want you to start. I want you to start with knowing, okay, well, I could take Maki's m and I could add it with Leilani's m minus 5, and I could add that with Kainoa's 2m. Now you say, I don't know how to do this math. Okay, again, we're going to look at that in Unit 1 when we start working with these letters. But for now, can you at least be with me that, oh, all I have to do with them is add them. Look at us, knowing the basics of mathematical reasoning. Wow, that really is going to open up doors for us for things that we have always thought were harder than they were. Woo! Shamika, we made it through. Super proud of you guys. This is the real problem that I have. Students will tell me, Kate, it made so much sense. I don't really need to practice. And I'll say, well, that's super great, but you don't understand learning. When you first learn something, we make a pathway to that information in our brain. But your brain is very good at recycling. Your brain's like my mother. It says if it's not used, let's just give it to Goodwill. If you don't use that new information you learned, your brain literally recycles that material. It's like you never learned it. So I want you to hit up the practice levels, okay? There's a beginning, an experience, and advanced level practice. If you're like more along the beginner lines, just hit up that beginning level practice. That is fine. We just need to reinforce that information. Now, if you're like, Kate, I'm not a beginner, you barely tell me anything. Okay, hit up the experience, hit up the advanced level practice, see how these simple concepts show up in pretty complex ways on the GED, and on the advanced practice, you're even going to see some college examples. But get your level of practice down so we can reinforce that pathway to that information. Your brain keeps it, says, oh, this is important, and you remember it come test day. All right, you guys, happy learning.